We have a few strategies for writing thread-safe code. That is code that can be safely executed across multiple threads. The simplest solution is not to share data across threads in the first place. This is called confinement because we want to confine or restrict each thread to have its own data. For example, instead of sharing a download status object across many download tasks, we could have each download task have its own download status object. When all these tasks are complete, we can combine the result. So this is the simplest strategy. I will show you how to do this in the next video. Another strategy is using immutable or unchangeable objects. An object is immutable if its state or data cannot be changed after it's created. For example, the string class in Java is immutable. If we convert a string to uppercase, we get a new string object. The original string object is not changed. So, sharing immutable objects between threads is totally fine because these threads can only read immutable objects. They cannot modify them. Another strategy is to prevent multiple threads from accessing the same object concurrently. This is called synchronization because we synchronize or coordinate the access to an object across different threads. We do that by using locks. So we put a lock on certain parts of our code, and only one thread at a time can execute that part. Other threads have to wait. So synchronization forces the code to run sequentially, which is against the idea of concurrency. Plus, implementing synchronization is challenging and error-prone. One of the problems we may run into is a deadlock, which happens when two threads wait for each other indefinitely. So thread 1 waits for thread 2, and at the same time, thread 2 waits for thread 1. That's a deadlock and can cause our application to crash. So, generally speaking, synchronization is bad and you should avoid it as much as possible. Another strategy is to use atomic classes in Java like atomic integer. These classes allow us to achieve thread safety without using locks. So if we increment an atomic integer, the Java virtual machine will execute the increment operation as one single atomic operation. It's not going to break it down into 3 smaller operations. That's why they're called atomic. They're like atoms. They cannot be broken down. And finally, another strategy is partitioning data into segments that can be accessed concurrently. Java provides a number of collection classes that support concurrency using partitioning. So multiple threads can access a collection object, but only one thread at a time can access a segment in that collection. So these are 5 common strategies we have for writing thread-safe code. Over the next few lessons, we're going to explore each of these strategies.